Alright, so.
Can I borrow a pencil?
Oh my god.
I haven't asked
Oh,
for
Are you
one
surprised?
in
Are
like
you surprised?
I haven't
Are you
asked
surprised?
in
Yes.
like 2 weeks.
You couldn't have even waited until before I started the video?
No.
That now people can know what I have to put up with on a daily basis, and how many pencils I have to give out.
Emery's not gonna watch this video. Emery's here.
That's why I missed you guys. I missed giving you pencils. Okay. Anyway, so today we are getting into proportional reasoning. Next one is statistical reasoning. And I forgot what our last chapter is, but we are getting towards the end. 15 lessons in days we have, so we're gonna be busy. So that's okay. Okay. So we're gonna talk about rates. We're going to talk about scale diagrams, 2-dimensional and 3-dimensional diagrams, area, how to buy something so you can save the most money, right? Well, we'll talk about some of those examples, okay? Surface area and volume, okay? So these are all rates, proportional reasoning. Okay, so from these 3 topics, or these 3 images, what do you think? Which one gives the best deal? Buy one, get one half off. Everything. Buy any 2 cards, get one free. Or limited time only, get 25% off the last ticketed price. What do you think? Which one would you buy?
Buy any, get 2 cards. Buy any 2 cards, get one free.
What
Yeah?
costs the most money?
Because 25% off, that's less than that, because that'd be 33% off.
Okay. Yep.
And buy one, get one half off, that'd be only.
Buy one, get one. Yeah, that's like 25% off, right?
Yeah, buy any 2 cards, get one free.
Okay, yeah,
Are
so
they all
you,
for cards or like?
that's another good point, okay?
Because it's still because everything's gonna cost a different amount of money.
Yeah.
Because the thing for buy one get one off could be like 3 times the price of a birthday.
Yep. Yeah, exactly, right? And so it's going to be related about what we're buying, what we need, and how much of things that we need, right? Typically, well, I don't know how often you guys go to Costco, but it feels like when you go to Costco, you're getting like essentially this deal right here, right? You're like buying large quantities and you're getting, probably like your third one at a discounted price, right? But then it's like, do you really need like 2 liters of ketchup for yourself?
Yeah.
Cody does. I don't.
I like French fries.
My buddy,
You
I,
just pre-buying birthday cards.
I'm a hot sauce guy. Well, and that's the other thing, right?
Yeah. Hot sauce.
So if your one birthday, or your one buddy's having a birthday, do you need 3 birthday
Yes,
cards?
I need
Yeah, hurry back, please.
You show how much you love them. Come on.
You gotta
Right?
show the
So,
sexual.
I don't know.
Buy
And
2 cards anyway.
it's also dependent on what we need, right? This one here, if you're just needing one item, this is probably your best bet, right? 25% off of your one item, right? If you need 2 couches, buy one, get one half off. Yeah. But anyways, we're going to see a bunch of different ways to present like a sale kind of thing, right? And what you guys are going to do, you're going to analyze it mathematically to find the best deal, kind of like what you guys are doing just here. Okay, so keywords. Get a pencil out. Write this down. These are important. Okay, rate. So, rate is a comparison of 2 amounts which are related and measured in different units. Okay, so rate. A comparison of 2 amounts that are measured in different units. So, for example, maybe you can read 240 words in 3 minutes, right? Measured in different units, so how many words you can read per minute. Or maybe how fast you drive, like 100 kilometers in 1 hour, right? So these are rates. Comparison of 2 amounts measured in different units. Okay? Can you guys think of any rates off the top of your head?
What do you mean?
I don't know. Right now, I'm thinking there are 5 people per this room right now, right? 5 people per room. Cody can eat 3 snap peas in 15 seconds, right? So something along those lines. All right. Okay, good. So when looking at best deals or best buys, sometimes we need to look at the unit rate to decide the best price. So what is the unit rate? So this is how much it costs to buy one of something. Okay? So like dollar, or like how much money is it to buy 1 kilogram of like beef, maybe?
So it'd be $1.27
Per kilogram, right?
beer fuel.
Or it could be like dollar per milliliter or dollar per liter. If it's fuel, it'd be like $1.30 for 1 liter of fuel now, right? Do you guys remember the lowest gas price you guys have ever seen?
Yeah, like 65 cents.
65 cents? Yeah, mine was 61.9 was the lowest I've ever seen gas.
Like current, like,
No, like that was when I was in grade 6.
yeah, isn't it like
It got really low.
It's like $1.30 now, yeah. It fluctuates, right? Yeah, that's okay.
No, it's bullshit.
Even though diet is still fairly cheap.
The what?
Diet is still pretty cheap.
Diet?
Diet.
Dye.
Diet.
Oh, dyed gasoline.
Yeah.
I'm like, what are you? Did you guys do some tie-dye? Okay, so that's the unit rate. Okay, so how much it costs to buy one? So, for example, if we jump back to this slide here, if we had 240 words per 3 minutes, is this at our unit rate? Remember, unit is for one of something, right? So we have words per 3 minutes. What would my unit rate be?
240 words per minute.
No, if it's 240 words per 3 minutes.
40 divided by 3, whatever that is.
Yeah, it would be 80 words per minute. Okay? Or like our gasoline, we had it in kilometers per 1 hour, right? It was 100 kilometers per 1 hour. Okay? So that's going to be our unit rate. How much it costs to get one of something, okay? Or, yeah, like 1 kilogram, 1 milliliter, how many calories burned in 1 minute, etc. Okay? For one. Okay? So, IGA and Superstore, comparing these two, you tell me, what is the better buy? $2 for 170 grams?
Super
no, wait, hold on, I just looked.
No.
$2 for 170 grams, or $1.97 for 340
I thought
grams?
that said 1 pound. Go up though.
This?
Yeah.
Yeah, 1 pound, 170 gram package, 6 ounces. That's all like one pound. Right?
So you're getting
Okay, well,
all of that.
How many grams in a
Wait,
pound?
Are you getting all of that for 1 pound?
Yeah, so,
Like the straw, like everything?
The blueberries and the strawberries?
oh, okay. Strawberries, 1 pound clamshell if it's the strawberries, or here's our blueberries right here.
Oh,
It's one or the other,
well,
yeah.
that's Superstore.
Yeah, so it's 170 grams of blueberries, or 340 grams. Which one do you guys want to buy?
Superstore.
Superstore, right? Yeah, for sure. Alright? So yeah, what was important in deciding between the two?
Well, I mean, Superstore has more.
How many, right? How much mass, right? Yeah. Awesome. Okay, what about this one? Pizza Pops. 4 in there, $2, or club size, so 1.1 to 1.2 kilograms. So this is like 3, I don't know, it's almost like 2 to 3 times the mass, right? What would you guys buy?
Well, Superstore. Bigger's always
Superstore? Bigger's better? Yeah. Brody, what do you say?
That's what she said.
Yeah.
You're gonna go for Superstore too?
Yeah.
I agree, right? Because think about it this way. If you bought 3 of these, you'd be at $6, right? And this is like $1 less, right? So yeah, Superstore for sure. Okay, let's go again. $5.49 for 6 burgers. Okay, packages of 6. Or you can get a box of 20 for $7.
Honestly, I'm thinking IGA, so Superstore burgers are gross.
The IGA ones are gonna be a lot. better.
Okay,
You
but,
can get
but
more
we're not
for
talking
your
about like
money.
quality.
Right,
Yeah.
okay.
Go on.
That brings, I'm really happy you said the keyword, Logan. The quality, right? And that's going to be a thing that you're going to come across. Just because something is cheaper, do you want to buy it? Right?
It can taste like shit.
Hold on.
It could not taste the greatest. Yeah, these ones are probably going to taste a little bit better, right?
Those ones are pounders. Those ones are probably
Yeah.
8 pounders.
These ones over here.
No, those ones are quarter pounders, but there's no way the Superstore
Those look
ones are quarter
Yeah, these ones you probably
They're
need like
finished shit, and
3.
There's like 20 of them.
You probably need
It's like
3
the
of
size
these.
of a freaking Wendy.
Yeah, exactly, right? Yeah, so that brings up the conversation, right? Quality versus quantity, right? Myself, I find as I get older, I'm leaning more and more towards quality, but like you pick your battles, right? You totally pick your battles. You can get like a really nice like frozen burger from like No Frills or something like that, which is comparable to that, and it's pretty fine, right? This is probably something I would get if you have like a bunch of people coming over and you're just firing up the grill and
Yeah.
you know you just want to put something in their belly, right? But yeah, if you're gonna be having like a nice dinner, maybe you're inviting somebody special, right? You're not gonna want to be grilling up those beef steakettes. They don't even call them burgers, right? The steakettes. All right, good stuff. All right, so let's get into some calculations here. So Natasha can buy a 12 kilogram turkey from her local butcher for $42.89. The local supermarket has turkeys advertised in its weekly flyer for $1.49 a pound. And there are 2.2 pounds to 1 kilogram. Which store has the lower price? Okay, so we have a local butcher and we have a local
So we
supermarket.
gotta convert the kilograms to pounds, and then I think that would work.
Perfect.
So
And yeah, Logan, you could totally do that. And if you would prefer, you can always go from pounds to kilograms, right?
2.2.
It doesn't matter which way you go, as long as you are consistent.
So I do like 2.2 times 12.
Okay, hold on. Can I just set this up first? Okay, so Natasha can buy a 12 kilo turkey at her local butcher. Okay, so here it is 12 kilograms for $42.89. Right? Okay, so the local supermarket has turkeys advertised for $1.49 per pound. Okay? So Logan, what did you want to do? You wanted to go to pound to kilograms?
From kilograms to pounds.
Okay.
0.25.
Yeah, okay, perfect. Now, do we have a unit price here?
No.
Nope. We want to find out how much it costs per 1 kilogram, right? So how would we do that, Cody?
Oh, 42 divided by 12.
Perfect. Okay, so, and units are our friend here. Okay, you guys need to get familiar with units. Okay, so $42.89, yep. Divided by 12 kilograms. And then what are my units going to be in, Cody? What am I dividing by what?
You're dividing by kilograms, so your unit's going to be, that's asking the price. It's going to be price for 1 kilogram.
Perfect. Perfect. Okay, so we do that, and then we will find it is $3.57 per kilogram. Now, like Logan said, we need to convert that into pounds. So how does that look like? Okay, and again, I want you guys to be using our unit conversions. Okay, so $3.57 per 1 kilogram. How many pounds are in 1 kilogram?
2.25.
2.2.
Close.
Okay,
I already said that.
so why my units will go from dollars to kilogram to dollars per pound? Because my conversion factor is that in every 1 kilogram, there are 2.2 pounds, right? So if we multiply, this is the same thing as dividing by 2.2, right? I just wrote it this way to show how our units cancel. Okay, so $3.57 per kilogram multiplied by 1 kilogram divided by 2.2 pounds. Kilograms will cancel, and I'm going to be left with dollars per pound, which is what? What did you guys get? Hopefully you got $1.62 per pound, right? Now let's compare to our supermarket.
Well,
So what do you think? Where do you guys want to buy?
you want to buy from the butcher. It's literally 1 cent cheaper.
Careful.
3 point.
Careful. $1.62 per pound. And
That's saving.
maybe I'll
Because if you're buying,
And 3.57 per kilogram.
Okay, look, but now we're both in pounds, right? So for 1 pound at the supermarket, it's $1.49.
Oh.
If you go to the butcher, it's $1.62.
Oh,
But remember, we talked about quality, right?
yeah.
Who would you rather support?
A
probably the
butcher.
butcher.
The butcher or IGA or co-op?
Butcher.
Butcher, right?
Butcher would probably be better
To
quality.
be
Would
fresh
be
meat,
local.
not frozen.
Yeah, exactly, right?
It could be,
You're probably gonna get
fresher
a
than-
better quality bird if you're getting it from the butcher, right? As opposed to getting it from the supermarket. It is cheaper at the supermarket, but remember we had that conversation between quality and quantity, right? So, and it's always good to support your local farmers. I'm probably just preaching to the choir, right?
I don't do cows.
I think cows.
All right.
Hey, that's a.
So let's look at this. So here is a conversation.
That's so funny.
I thought it. I thought it was funny.
I was thinking about Lisa, hey.
Okay. All right, folks, let's go. So you're on a road trip. You're going to Los Angeles, 270 miles away. Okay.
So if you drive 270 miles per hour, you make that an hour.
You get we have 15 gallons. Okay. And you get about 35 miles per gallon.
What?
Okay.
So, are you gonna make it?
No, not even close.
Okay.
Are we gonna need to stop for gas?
Yeah. Well, I mean, it might not be a gas station, so you might just have to stop.
Well, would it be a bad idea to stop?
How big is your engine?
No.
Wait.
How big's your engine?
What? Engine.
You don't even know how big the engine. You know what the
Wait, if you
combustion
hold-
rate is,
If you hold 50.
or the fuel
The
efficiency.
tank only holds like 32 liters, or 34 liters.
We have 15 gallons.
They times it by 35.
No, times 15 by 2.2, you have like 35 liters in your tank.
Why are you multiplying it by 2.2?
Oh shit,
We're
that's
converting
gallons
into
into
pounds.
gallons into liters is different.
Right? And
What's gallons into liters?
it doesn't matter because we're all in gallons here. Gallons per liter. I think it's like 2.7. I don't know. 3.7. Final answer is my guess. Google.
Right.
I'm saying Actually, I'm gonna go 3.6 gallons per liter. But anyways, it doesn't really matter about this one, right? Because if we know it has 15 gallons and you get about 35 miles per gallon, you can do 15 gallons
You would make it.
times 35 miles per 1 gallon. What did you get?
Because 270 divided by 35.
Nope, 15 times 35, Cody, is what you want to do. Right? Because we have 15 gallons in the tank, and we get 35 miles per 1
Okay,
gallon.
never mind. You would not make it.
What did you get? Did you multiply it?
525.
15 times 35?
I got 525.
525?
Yeah.
And how far do we need to drive?
270.
We're there with like.
So,
20 spare. It's all this.
this is how far you get on a tank of gas.
Okay, what vehicle is this person driving that they get that
Putting
good
it
fuel
in,
mileage?
if putting in the Dodge, like Grayson Dodge, it got down to 6 miles.
Maybe this is a, well, it can't be a Tesla. Maybe it's a hybrid.
35 miles, yes. It's gonna be a
Savage
yeah.
truck.
A hybrid, yeah. But
It is.
at this
I
fuel
want that
consumption
vehicle.
rate, right? And the distance that this person needs to go,
I
we're
need to
okay.
Find out what vehicle is.
What?
I want to know vehicle.
It's a hybrid. It's a hybrid. Hey, let's get to work. You
I
too.
feel like it's in.
Yeah, what's up?
I'm not sure what formula to
It's
use.
definitely.
Posted on.
Okay, so this person's gonna make it. They're gonna survive, right? Okay, now let's get into a calculation question though, okay? So the gas tank of Mario's new car has a capacity of 55 liters. The owner's manual claims...
Wait, I was right though with 7.7 how they would have made it.
What?
Because they would have went. I got 7.7.
7.7 what?
So. Like I got 7.7, so they would only use 7.7 gallons. So they would only use half their tank.
Oh, you did something with... Oh, you divided 270 by the
But-
miles per gallon, and it told you how many gallons you needed?
Yeah.
Okay, gotcha. Yeah, and there's a lot of things you can do, but it's really important that you use your unit conversions because it will actually, your units will tell you if you got the right answer or not by just looking at the units, right? Yeah, if you get, yeah, we'll continue, but yeah, units are your friend, and it's a good way to indicate if you've gotten the right answer or not. Okay, so the gas tank has a capacity of 55 liters, and the fuel efficiency is 7.6 liters per 100 kilometers on the highway. Before Mario's first big highway trip, he set his trip meter to 0 kilometers, so he could keep track of the total distance that he drove. So he started with the gas tank full, and each time he stopped, he recorded the distance and the amount of gas he purchased. So the question is, on which leg of the trip did Mario have the best fuel efficiency? Okay, so for word problems like this, let's write down what we know right off the hop. Okay, so what does this question tell us? Well, we know the volume of the gas tank is 55 liters, right?
Yeah.
Okay, and what is the efficiency? It did tell us. It is 7.6 liters per 100 kilometers.
Yeah, that's also good mileage.
Yeah, that's not bad actually. It's probably like a newer vehicle. Now, what do we want to do anytime that we're given a rate? Is it in its base unit? Its unit price? How many kilometers do we get 7.6 liters on?
100 kilometers.
Yeah, so what should we find?
Oh, you could divide 100 by 7.6.
You do 7.6 divided by 100, right? And that will tell you how many liters you get per 1 kilometer, right? So if you do that, you'll get 0.076 liters per 1 kilometer. Okay? So that's according to the manual, right? That's all good. So, we have a fill up here. So, after fill up 1, his distance is 645. Now remember, this is on his odometer, right? Okay? So, he drove, okay, so first leg, he drove 645 kilometers, and he used 48 liters of gas, right? Let's do it the other way around, because they've given it in liters per kilometer, so let's do it the same. So 48 liters divided by 645 kilometers is equal to 0.076 744 liters per kilometer.
I want this type of fuel mileage.
Yeah, you probably don't get it in your truck.
No, I get about 23 liters to 100 kilometers.
Oh
Yeah, it breaks the bank.
man, seriously. I used to have an Xterra.
Yeah.
And yeah, that was like to get to and from Calgary, it would cost me like $80.
Yeah, that's probably be what it would be. Well, I put in died at least, so it's not so much.
Okay, so that was for the first leg. Now, for the second leg, how far did we drive in between leg 2 and leg 1?
I'm gonna go on a rant and say 392 kilometers. 391.
The one you just said,
392.
392. Yeah, how did you calculate that, Cody?
Brain.
No, I know, but what number did you subtract from what?
Subtract 400 from 1,000.
You subtracted the
600 from
first.
1,000.
You subtracted the first fill-up distance from the second fill-up distance, right? Because in between fill-up 1 and fill-up 2, they drove 1,037 kilometers minus 645 kilometers, and just like you said, the distance is 392 kilometers. Now let's find out how many kilometers we got per liter, or liters we got per kilometer. Okay, so we had 32.1 liters divided by 392 kilometers. And that gives us 0.0819 liters per kilometer. So, what was the more efficient leg of the trip?
First leg?
Yeah, and why?
Because it's less liters per kilometer.
Yeah, exactly. Less liters per kilometer. You bet. Absolutely. How do you feel about this stuff? Okay? Yeah, you're interested in this, Brennan? Good. Yeah, I feel like this is like actually like relevant. Useful, exactly. So, suppose that tap water is flowing from a faucet at a constant rate, is used to fill these 4 containers here. So we have a graduated cylinder, same diameter all the way up, right?
Yeah.
Okay. Flask has a wide diameter at the bottom and it gets more narrow as we get to the top, right? Beaker, wide, same diameter all the way. Drinking glass, it's narrow at the bottom, and as you get closer to the top, it gets larger in size, right? So, these 4 different containers are going to fill up at different rates, right? Why? Well, because they're shaped differently,
Yeah.
right? Okay.
If they're all the same volume, they'll fill up at the same time.
No.
Nope. Because, like, think of it this one down here, right? If we have a really wide
Yeah,
base,
they're all gonna be full at the same time.
No.
if
They're all
okay,
the same shit size.
you're right. The time
Yeah.
that they take, if they're the same size, will fill up at the exact same rate.
Which doesn't really make sense then, because then all those numbers, then the whole right side, the diagram should all be at the same height. Should they not be?
Okay. But in these ones, right? They're different height of containers, right?
Oh, yeah.
Like the graduated cylinder is 10, 20, 30, and say the flask is only like 10, right? If they could hold the exact same amount of volume, if they were the same volume, then they would all fill out with the exact same rate. You're absolutely right. But they're shaped differently, right? So the rate at which they will fill up is different. So let's look at this graduated cylinder. Okay? Is it constant, the diameter, the whole way up?
Yeah.
Yes,
So it's A.
it is. It's A, you say, hey? Yeah, okay. And why isn't it C then, Cody?
Because C would be probably the last. Because it's the tallest one.
The graduated cylinder is?
Yeah.
Okay, yeah, it's the tallest one, you bet.
Goes
And-
third.
And it's gonna go up linear, like as a linear relation, right? Because that it's just it's the same diameter the entire way up, right? So yeah, this is definitely A. Right here.
And drinking glass would be B.
Careful. Is it the same diameter all the way up? No.
No,
What is the same diameter all the way up?
Well, a beaker.
The beaker, right? And is it as tall as the graduated cylinder?
No.
No, so it's
I
gonna be.
said drinking
You said
glass
B.
was B.
Oh, did
The
you?
beaker's C.
Oh, okay, yeah. Sorry. Yeah. So beaker is C. Okay, good. Yeah, I just wanted to compare those two because I thought that was gonna be like the easiest comparison there. You say the
Oh, no,
drinking
no,
glass,
Never mind. The drinking glass is D
and why is that?
because it's little at the bottom, so it goes quick and it curves over. 'Cause it's-
Excellent. Good. And then lastly, we're gonna have the flask, right? It's really wide at the bottom, so it's gonna take a longer time for it to fill up. But once it gets near the top, it's going to increase at a faster rate. Yeah, you bet. Good. 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 Okay. So yeah, rates of change, right? Rates of change. Different containers. If they had the exact same volume, they would all fill up at the same time. But because they're shaped differently, the rates at which they fill up will be different, right? Agreed? Just like if we're talking about like depth and time, the rates at what they fill up will be different, right? Just because of the different shapes. Okay, good. So this graph here, this is a distance versus time graph. Okay, you guys would have gotten practice with this if you were in Physics 20, but you weren't.
Yeah.
So you gotta learn it in
I was
math.
in there for one day.
Were you?
Yes, one day.
And then you
First
left?
day. Yes.
I don't even remember seeing you that day.
Didn't do anything.
Anyway, so this is a distance versus time graph, right? So distance is how far you have moved, right? Okay? Yeah, so of this region here, what interval of time is the ATV traveling the slowest? Which interval of time is this ATV moving the fastest? And how do you know?
It's moving the fast. From.
It's kind of hard to analyze it just by looking at the graph, right?
Over which interval? Well, it'd be from, I don't know how to explain like what dots.
Let's
Well,
call,
3 points,
this can be interval 1.
then it'd be interval 3.
I know it.
No, because interval 4 draws.
Right. But it's still,
Slowest.
it's still moving, right? Think of speed as covering a distance and amount of time, right?
Okay, well then it's 4.
Speed is equal to distance over time. So which region covers the largest distance in the shortest amount of time? Cody said 4. I agree. What happened in 4? Well, let's see. We started at 5 kilometers. Our distance is back to 0. And that's in like 5 minutes, right? So we went 5 kilometers in 5 minutes. What about leg 1, right? We went 2 kilometers in 30 minutes.
Yeah.
Here, are we even moving during region 2?
No, not at all.
No, it probably like stop for lunch or a little bit of a snack, right? Maybe they found a nice scenic spot. They're not even moving. 0 kilometers, 10 minutes. And then what do we got up here? We go from 2 to 5, so we went 3 kilometers
This
in
person's driving slow.
25 minutes. Well, if you're out ATVing and you're in some like unfamiliar terrain, you might be taking your
You
time.
go fast, you crash. It's just the way.
But that's this person on the way back. They're like, oh crap, we better get back. We gotta go to lunch, right? Or we gotta get to work, right? So what is it moving the slowest in? Where is it moving the slowest?
Well, 1. It's not moving.
Okay, yeah, so 1, it's, okay, that's fair. Yeah, I said 1 or 2. I put like an asterisk beside the 2 because it's not moving, right? For sure. And which is this moving in the fastest? We said that was in interval 4, right?
Yeah, and then B is interval 4 as well.
When, what time
Oh,
does the ATV start to return to its starting position?
65 minutes.
Yeah.
When does it start to return?
That's 60 minutes.
Starts to return at 60. And when do they arrive?
65.
Yeah, good. Okay. What does the horizontal segment of the graph represent right here? What does that mean? Are we moving? No, we already said that they were stopped, right? ATV is stopped. For lunch, for a flat tire, for an overheating engine. I don't know.
Like, really doubt it's gonna be overheating at the speed they're going.
Maybe they were
They're
towing.
not running.
Maybe they were towing a bunch of lumber.
Maybe they're burying a body. Who knows?
Maybe they're burying a body.
They need a fountain.
They got up here, they got rid of it, and they're like, "All right, let's get out of here." They just weren't sure. They thought segment 2 was going to be a good spot to leave the body, but then they realized it was too close to civilization.
I still don't think 5 kilometers is far enough. I mean, like,
You should,
whatever works.
if you're dumping a body, you should be out there, right? Yeah, yeah, not only 5 kilometers away. Okay, so have we talked about slope in here? Slope, rise over run. How do we-
Slopes.
I feel like we've talked about slope a lot.
Probably.
Well, let's put some rubber to the road, okay? In order to find the answers to some of these questions, so involving rates of change, and essentially what you guys were doing here, you're finding the rates, like the slope, right? Because we found that, well, let's go back here. So slope, so let's go to grade 10, I think. Y is equal to mx plus b. You guys remember this one?
Yeah.
What is this? Is this a quadratic or a linear function?
Probably one of the two.
What?
One of the two for sure.
Yeah, that's why I asked.
It's linear.
It's a linear, right? Because what's the exponent on 1?
An X. Oh, 1. Oh yeah, it has to be X to the power T would be.
A quadratic, right? Yeah. Okay, so y is equal to mx plus b. What does m tell me? What does b tell me? You don't remember?
No.
So m is going to be the slope, and b is going to be my y-intercept. Okay? And again, this is a linear function. You guys need to know. You guys need to know this.
You want to teach us it then? Because grade 10 math was not a fun time
That's
for learning.
I just taught it. This
Yeah,
is
that's
this is pretty much what you need to know. Okay, m is the slope, and b is going to be your y-intercept. Now to actually calculate your slope, slope is equal to the rise over the run. And typically on a graph, what goes up and down? Is that the x or the y-axis?
Why?
Y-axis, okay, good. So rise is my change in y, and my run, what goes horizontally? X. So my run is going to be change in x. Okay, this can be expanded to y2 minus y1 divided by x2 minus x1. And that is going to equal your slope, which is m. Okay, slope can also be considered as the rate of change in a graph, right? We want to find how far something has moved in a particular amount of time, right? That's speed, right? So let's think about it this way. So speed is equal to what?
Flash.
What?
Flash. Lightning McQueen.
Well, how do I measure speed?
By
On the highway, what does it say on your highway signs?
A suggestion.
Per hour. Kilometers per hour, right? And is kilometers a time or is it a distance?
it's a distance.
Okay, thank you. And what is hour?
Time. An hour.
And what typically goes on the x-axis?
Distance.
Time.
Time.
Yeah, I got
And what usually goes on the y-axis? Distance, right? So just like what we did, so the change in distance over the change in time. And again, anytime you see a delta, a triangle, it means final or y2 minus y1 or x2 minus x1. Okay? Good? Logan? You fine?
Yeah. Just think about me killing Brandon.
Okay,
Why?
so
Why?
we are going to make, well, you guys tell me, yes. Wait for Cody to come back, please.
I think you went to get a sandwich.
Yeah, you can wait for him to come back. Okay, so a car travels at 60 kilometers per hour for 30 minutes. 60 kilometers per hour, is that a distance? Time and a distance, meaning it is?
Slow.
Y1 minus Y2.
Yeah.
I don't know.
Okay, if you are driving at 60 kilometers per hour, that is your speed, right? That is your speed. So this is speed, and this is time. So what type of graph are we going to make?
Speed time.
A speed time graph, exactly. Or a velocity time graph, whatever. Velocity time graph. Always label our graphs, right, Brennan?
What?
Always label our graphs?
Yeah, Brandon. Oh. Yeah, I struggle with that.
Yeah. Okay, so what's going to go on my x-axis?
Numbers.
Which ones? Time or speed?
One's with some numbers on.
Time or speed?
On X?
I mean,
Yeah.
Speed.
time.
Time, always time.
Logan, you're in this class and I knew that.
Never mind. Get to work back there. Okay, time in minutes. Okay, and what's gonna go on our y-axis then?
Speed.
Speed. Let's go.
On speed.
And don't forget your units, right? We're in minutes and we're in velocity.
Hey, pal.
Hi. Tomorrow.
Oh, I thought you were going.
Yeah, tomorrow. Mr. Don's gonna come substitute
Yeah,
for
you
you
want
guys
to hang
tomorrow.
out together. Brady.
Thank you, Mr.
I was
Bowden.
gonna say Brady. Brady. I need you to come see me about getting.
Okay, so velocity on the y-axis, time on the x-axis. Always time on the x-axis, okay? So, we know a car travels, hey, get out of here. A car travels at 60 kilometers per hour for 30 minutes. So we need to do some axes. So it goes to 60 and up to 85. So I just want to make sure my range is good. So I'm going to do each box as 10. So 10, 20, 30, 40, 50, 60, 80, 100, 120. That will be plenty. And then my time, 30 minutes, 10 minutes. In total, I have 44 minutes. Okay, so I'm going to set it up this way. So 5, every 2 boxes is 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay? 10, 20, 30, 40, 50. Okay, so now that we have our axes labeled, we can go ahead and plot some points. So a car travels at 60 kilometers per hour for 30 minutes. So we start here, and he drives at that speed for 30 minutes. Okay, so it's probably going to help us to just write the coordinates of these points here. Okay, so 0 and 60. This one is 30 and 60, right? Then what's my next one? So it increases its speed to 85 kilometers per hour, and that is in 1 minute. Had to include that in there. Okay, so in 1 minute, so at time is equal to 31, it increases its speed to 85. So 85 is going to go about here in 1 minute. I'm just going to move this point here. 30 and then 60 and then 85 is about here in 1 minute. Okay, 31 and 85, right? Time is 31, speed is 85, and stays there for 10 minutes. Okay, so now we're going to go 10 minutes up to right about here, and that point is going to be 41 and 85, right? And then it decreases to 30 kilometers per hour for 2 minutes, and that takes 1 minute again. So here's 41, it's going to go down to 42 and 30. So 30 is somewhere in here, and 42 is going to be somewhere around there. And then it continues to drive at that speed for 2 more minutes. Okay, so just to clean up my points, I have a 42 and 30, and then a 44 and a 30. Okay, let's go ahead and connect these points. Something like this. Okay, so draw a graph to represent the situation. This is it. So we have a velocity and a time graph here. Okay, so I don't know. I think the hardest part for these is just potentially getting your coordinates like one off, right? Yeah. So just I find that it's just like easiest just to write it our coordinate right beside the point, just to keep track of it a little bit easier. Okay. This question, you don't actually have to find like your greatest rate of acceleration or anything like that. But if you were, right, what do we, and we'll get into that on the next one, right? But just by looking at this one here, what is our greatest period of acceleration?
Probably either
I remember the greatest change in speed when the shortest period of time. Where do we see that?
From, I'd say 30 and 60 to 31 and 85.
You think so?
That's what I'm guessing.
Any other thoughts on that? So in 1 minute, Logan, we go from 60 to 85. So in 1 minute, we increase our speed by 25, right? What about this minute right here, though? From 41 to 42,
Oh, yeah.
right? It drops down 55 kilometers per hour, right? So that is going to be our biggest region of acceleration, right? Acceleration is change in velocity. Velocity is a change in displacement. Okay? All right. Now, I want you guys to create your own graph here, okay? Okay, so we have greenhouse gases on our y-axis, we have year on our x-axis. Let's plot some data. So our first one is at 1990. We have 103 megatons, so it's gonna go about here. Okay, and again, I'm gonna write down my data points, but I'm gonna do the shape first, okay? 95, we have 127, so about here, say. In 2000s, we have 151, so about here. 2003, we have 161, so 2001, 2002, 2003, and is 161. And 2006, we're at 158, so 2006, 158 is about there, okay? So, we have a region there, a region there, and it kind of goes down like that. Okay, did you guys look something like this?
Yeah.
I hope, yeah, okay. So let's write down our points. So 1990 and 103. We have 1995 and 127. We have 2000 and 151. Up here we have 2003 and 161. And lastly, 2006, 158. Okay? So, if I want to find the period which the emitted fuel was increasing at the greatest rate, what am I essentially trying to find here?
The greatest difference between numbers.
Yeah, the greatest difference between numbers. And also like the greatest slope, right? We are going to calculate slope here. So somebody remind me, how do I calculate slope?
It's something over something.
Run over rise?
Run over rise. Yeah.
It's close.
It's not run over rise.
It's close to that.
Rise over run.
Rise over run, okay? Slope is rise over run. Now, what is my rise on this graph? What is rise? Is rise x or y axis?
Why?
Okay, so change in y over change in x, right? What is my y?
Your megaton.
Of greenhouse gases, right?
Yeah.
So what is my change in, let's just say, greenhouse gases over what? What's my delta x? What's my change in x?
Year.
Yeah, change in time, right? Change in year. Does that make sense?
Yeah.
This is important. Okay? Slope is rise over run, which is y over x. So we just find what is on our y-axis, what's on our x-axis, right? Okay. So we have 1, 2, 3. Are we increasing here? No. So do we need to calculate our slope here? No. We're just looking for increasing. So we have 3 regions, right? Now, let's just start from 1. Okay? We'll just start at region 1. Okay? So slope is what? How do I calculate slope? Tell me. What's slope?
Rise over run.
Rise over run. Good. And then what is rise? X or y?
Y.
Delta y, right?
Yeah.
Over delta x. What is delta y? Or what is delta x? Anytime we have a delta, it is
Solving for it or
change. Yeah. Change.
changing that.
And what minus what? y2 minus y1 over x2 minus x1. Okay? So, For my region 1, this is x2 and y2. This one right here is my x1, y1. So for region 1, what is my y2? So slope for region 1, m is slope. So my y2 is 127 minus my y1, which is 103, divided by my delta x. So what is my x2, Cody?
Your x2 is, can't read that.
1995.
There you go.
And my x1
Is 1990.
is 1990. Now, when you guys are putting this in your calculator, use brackets. Otherwise, you're going to get a silly answer.
24 over 5. And that-
Yeah. And then tell me how many megatons per year. Right? Megaton year. So
So it'd
127.
be 24 megaton per year.
Say that again?
24 megaton per year.
No. So if you did it that way, you'd get 24 megatons per 5 years.
Or per 5 years, sorry. So then 24 divided by 4 is 6, 12, 8. So 6 megatons per year.
24 divided by 5. 5 years here. 95 to 1990. Y2 minus Y1 divided by X2 over X1. Okay?
28 megaton a year.
4.8 megaton a year. Okay, so for number 2, what would it be for number 2? Okay, so you guys do 2 on your own, please.
That's all on ours.
Yeah.
Yeah, that's fine. You guys can do it right where they both space.
He's talking about
Like do segment 2 now.
Oh.
Okay, so segment 2 will be right here. So this point right here, is that going to be my y1, x1? Or is that going to be my x1 or x2, y2? For region 2.
your X2 and Y2.
Yeah, you bet. And what's this one gonna be?
It's 1 and Y1.
Perfect. Okay, and what is slope? How do I calculate slope?
4.6 megaton per year.
Careful. What's your y2 here, Cody?
151.
And what's your y1?
127.
What is your
51 minus 1. Wait, 1.
and what is your x2? 2000 minus 1995, which is our year.
Oh shit, I got 23 the first time. There we go.
Okay, be careful with our calculators, right? Brackets, 151 minus 127
4.8.
is 4.8. Whoa. Were you suspecting 1 and 2 to be the exact same slope, Cody?
Yes, they're the same difference.
Same difference. Well, now that we look at it, it's like, oh, well, it's the same. Right? It's pretty constant, right? Okay, last one. Number 3. Number 3 is up here. Okay? So same thing. How do I calculate slope? What is slope? What is slope? y2 minus y1 over x2 minus x1. In this case, my change in y is 161 minus 151 megatons divided by the year was only 2003. There's only 3 span there. 3 span year.
Which would be 3.3 repeating megatons per year.
Perfect. So, now let's circle back to our question. During which period was the fossil fuel emitted increasing at the greatest rate?
Well, from 1990 to 2000.
Yeah, well said. Well said. Yeah, from 1990 to 2000, you bet. And then, yeah, so with these word problems, you guys should always summarize your answer. So therefore, greenhouse gas emissions were the most between two, what did we say, Cody?
2000, or 1990 to 2000.
Yeah. All right. So, your assignment for the remainder of today's class, just work on some of those practice problems at the back. You guys have 5 minutes,
5 minutes.
because it ends at 11:25, right? No, 35.
35.
35? Yeah. So yeah, you guys got like
I wish it.
17 minutes to practice here.